my channel Learn at Cloud Analytics. As part of a Power BI Zero to Hero series, we have so far looked into the basics of Power BI, and we've also looked at the data transformation by using the Power Query editor. And in this module, we are going to cover one of the major topics in Power BI, which is nothing but data modeling. So, data modeling is a vast subject, and therefore, I try to put in as much information as possible. And I would be trying to cover the at least the majority of the topics that is needed for each one of you, starting from the basics to that of the advanced topics. Now, with that said, let me quickly go through the topics which would be covered in this particular video. So today I will be introducing about data modeling, the importance of data modeling in our report, and then I will also try to cover the basic terminologies that each one of us should be aware of while performing a data modeling in a Power BI. And then I will also try to compare the relationships with that of a merged query, because I know that most of us would have this query in our mind, assuming that perhaps I can go with a merge query or maybe with a relationship with a data modeling, and or vice versa. And how different is that of a merged query to that of a relationship model, and which one is efficient to the other one as well, right? And then I will be trying to cover few examples with some live scenarios, and we try to understand each of these topics in a deeper way. And based on the time, we will try to cover other elements. If not, then I will try to split this into different days, and I will try to create content based on the topic wise. Now, with that said, I've tried to create some slides on some fewer elements, which is like the basics of the data modeling, because I felt by putting them into some slides, it would be helpful for you to easily understand and grab the information, because there is some theoretical information which I should be covering as well. Here on the first slide, I'm trying to present you with a basic Power BI desktop workflow, which indicates that right from getting your data inserted into your Power BI workbook to that of publishing the report to the Power BI service. So these are the basic stages or the basics workflow of a Power BI desktop reporting part. So the first step here is that we try to get the data from the relevant data source. So let's say that if your data is stored in a CSV file or maybe in a proper database like a Oracle or a SQL Server database, then you try to connect to that particular connector through the get data option on Power BI desktop and retrieve that particular tables into your Power BI desktop. Now, once you get the tables imported within Power BI desktop workbook, and then you try to analyze or look at the particular table structure to see if the data is looking good or if there is a need to perform any data transformation. So there could be some scenarios where your data might have a lot of null values, or maybe the data types might have been incorrect. So you might need to modify or correct that particular data types into a valid ones, and perhaps there are slightly few other elements that is needed for data transformation as well. So you try to do all of them by using the Power Query editor in Power BI, and once all the data transformations are complete and that you're happy with your data, how it looks like finally, and that then you try to save it, and then comes the next part of the key element, which is nothing but the data modeling. Now let's try to understand why is this particular phase of the reporting is even crucial, and how is it even important to efficiently improve the overall performance of your reports that are getting deployed on the Power BI service. So with that said, let me quickly go into the data modeling portion. So before we actually understand the definition of a data modeling, I try to put a business scenario here so that it's easier for us to interpret and understand why this is important in our day-to-day requirements. So here I have taken two different tables, customers and orders. And as you could see in my customers table, I have taken four different customers, namely A, B, and C, A, B, C, and D. And orders table has all the order relevant information with the customer ID as well. So we know that for which customer what order has been placed and what is the sales amount for that particular customer. Now, by using these two tables, I try to import it within Power BI, and the problem statement that they have put here is that when they try to analyze the total sales for each of the customer, uh, uh, they try to see the same values seen on the report, which means that if you see on the tables, right, if I try to drag in the customer name column from the customers table, which has A, B, C, and D four values, and the sales column from the orders table onto my same visual where I have the customer name pulled in, then eventually I should be looking at for customer A what is my total sales, because I'm not extracting the order related information onto my view, and therefore I should be looking at the sum or the aggregation of my total sales for that particular customer, which is for customer A it should be 300, and likewise for customer 2 it should be 250 plus 300, which gives us 550, and for customer C it should be 350 and 400, which is nothing but 750. Now let's see what happens here. So here, this is on my Power BI desktop. Within my data model, you could see that there are two different tables, customers and the orders, like I said earlier. So I've imported both the tables into my Power BI desktop, and therefore you could see both the tables listed here. Now, when I try to extract the customer name and the sales onto my report, I basically see the same value provided for all the four customers, which is actually incorrect because, as we have seen previously, uh, all the four customers have different values and it's not the same, and therefore this is actually not called as a data model. Now, what is a data model here then? So a data model is nothing but it is a collection of multiple tables or multiple data sources. So let's say when you're trying to create any report, right, we often connect to multiple tables or multiple data sources, and in order to get our connected data ready for use we require modeling. So, what does modeling do? So, modeling tries to bring all the data that is needed to work together and helps us to create a cohesive report. So, here, as you could see, by adding a relationship defined between the two tables with the arrow mark as highlighted within the circle. As soon as I have defined the relationship between the customers and the orders table, the data on my visual has automatically been corrected and I can see the right data being displayed. And that gives the right data populated on my visual level. So, this is what is expected by the end user, and therefore, it's crucial to understand what is a data modeling. So, when we try to work with multiple tables, then there is a need to define the relationship that exists between or among those tables in order to get the right data extracted or populated on our visuals. So, now with that said, let's try to understand this new terminology that was introduced now, which is nothing but the relationship. So, what is a relationship? So, relationship is nothing but it tries to create a logical connection between the different tables or data sources. So, what is a logical connection? So, logical connection is nothing but it doesn't actually create any physical structure between the two tables, but rather as the query as in when there is a need to execute a query between two different columns coming in from two different tables, that's when it actually goes into the two tables data modeling structure and tries to interpret what kind of a relationship exists between those two tables, and accordingly it would try to extract the data and populate it automatically on the report level, that's on the visual level. So which means that the queries are been executed on the physical memory and those are not been stored, and rather these are executed as and when the requirement or there is a need to connect those two tables. Okay. I know that I have spoken a lot and it's too difficult as a beginner or as a naive user like you and me. So let me try to split this explanation into a simple steps. Okay. Now let's say that in my prior example, I try to drag customer name column from my customer table onto my visual. Okay. And then I also try to drag and drop my sales column from my orders table. Now, dragging the column is nothing but I'm trying to query the customer name column from my customers table and trying to query the sales column from my orders table. Now, when I query the tables based on a specific column, we are also trying to explain these two tables how they are connected between uh, like both of them, right? So there is a connection established through the definition of a relationship, and that is where when these two columns are retrieved, only then Power BI will internally go and try to understand how are these two tables related to each other. So as you could see, there is a denotion specified which says number one on the customers table and an asterisk symbol on my orders table, which indicates that my customers table has one and orders table has many. So it has the cardinality of one to many cardinality, or in other simpler words, every record of my customer table has multiple records in my orders table. And why is this happening? Because the same customer can place multiple orders, right? And that is why there is a relationship that says it has a one to many cardinality, and based on which the data has been queried on the respective tables during the execution of the query alone, and then it gets populated on the visual, but it's not getting saved on the physical structure. uh, Ideally, or maybe I can show this more in the demonstration part. So for now, just try to understand that by defining a relationship, we are just telling how these two tables are connected with each other, or how are they both related to each other. So the customers table, because it's a dimension table, it has always a one cardinality, like a one number, and the orders table is a fact table, and therefore it is always having a asterisk symbol next to that, which indicates it has duplicate information. Okay, so I'll try to repeat this again. So relationships try to create a logical connection between the different tables or data sources, and it helps us to run the queries for that particular related data across the tables. Now, each block in that example that I've shown you, this is a table, and this below rectangle block is also another table, and these two blocks are connected through a relationship which has an indication of a number and an asterisk followed by an arrow. Okay, so that is nothing but your relationship. All right, now that we understood about the basics of a relationship, now let's try to understand how are these relationships being created. So, in order to create a relationship, just drag the field from one table and drop the field on the related field of the other table that we would like to link. Okay, so for example, these two tables, what is a common column? So I have the customer ID. So using my customer ID column, I can relate both the tables. So I can just drag my customer ID column from my customer table and place it on my orders table. And that's it. Power BI will take care of the defining the right relationship between these two tables. Okay. So that is one way of creating a relationship, which is nothing but the manual way. The other way is automatic. So automatic is something which Power BI, through its AI intelligence, it can identify if there are common columns existing already among the tables, then it tries to create the relationship by default. And you can enable or disable this auto detect feature by going into the data option settings. If not, you can just do it manually as well. So I will be demonstrating these topics as well in detail in the next few seconds. All right, now let's try to go back to the example. So I'll go back to the Power BI desktop and let me close this. Okay. So I just opened a new Power BI desktop workbook, and now let's try to connect to a sample data. So I go to the get data option and select my Excel workbook, and I'm trying to connect to the Superstore data set. Okay. So that's the first step as we saw in the entire Power BI desktop workflow, right? So here I'm trying to connect to the orders table, and I can see the preview of my data on the right side preview. And then I'll try to preview the data for my people, and I try to select that as well. And let me see what is my returns table looking like. And I will also try to select the returns table. Now let me go to the transform data. So it's always a good practice to go to the transform data instead of loading all the tables directly into Power BI desktop, because then you can try to look at what columns is needed for your reporting purpose and also what kind of a data transformations is needed. You can all perform that within the Power Query editor by selecting the transform data. So let me select transform data here quickly, and that opens up the Power Query editor window. Okay, so this is my Power Query editor. So let me quickly do some cleansing of my data. So let me call this table as returns table. And as you notice, the first row is not identified as the column headers. So therefore, let me go and use this, use first row as headers enabled. So I select this so that automatically the first row is identified as the column headers of this table. And this looks pretty good. And now let me go to the other two tables. So this is my people table, and as you could already see, the first row is not correctly identified as a column header. So again, I would try to implement the same data transformation. So I try to click on use first row as headers, and then I go to the orders table. So here it looks pretty good. I think there is not much to do. It's already in the right format structure. Okay, now what I try to do is I'll just quickly close and apply. And as you could see, when I click on the close and apply, it saves the data and gets loaded within Power BI desktop. So all the data is imported within Power BI desktop, and you can just go to the table view so that you can preview the data of your table, and you can understand what data is residing in. And this is only available when you have the import mode as the data connection. But if you have connected via direct mode with to a database, then this data preview is not available. So, I mean, if you go to the table view itself will not be accessible because it's in direct view connected mode. All right, now let's try to see what kind of a transformations, or maybe let me go to the model view. So in order to perform any data modeling, we need to go into this model view uh, pane, and here you could see that all the tables are listed, and automatically if it identifies any relationship, it tries to create a relationship between the tables. So here within the tables that I have loaded, that is returns, orders and people, Power BI has already identified that there is a relationship existing between my people and orders table, and in order to identify through which, I can just select this particular line or this particular relationship, and right click on this line and say properties, and that gives us this particular edit relationship window where I can easily uh, preview what which two tables are connected with each other and based on which column. So my orders table has the common column which is region, and the people table has a common column which is region, through which both the tables are related with each other. And Power BI has automatically detected what kind of a cardinality is existing between these two tables. So do not worry, I know cardinality is also a newer term, but we will try to explain it in the next couple of minutes. So for now, just understand that you don't need to define what kind of a relationship exists between both the tables, but you just need to ensure that all the tables are correctly connected. Now let me try to save, and just in case if this particular relationship is not identified, now how do you define the relationship? So let me quickly delete the relationship. And now if I go to this home ribbon on my data model view, there is an option to select manage relationships. So just click on manage relationships, and now here you can select new relationship. Click on new, and here you can select which tables you're trying to connect to. So here I've selected orders, and then I've selected people, and automatically Power BI has identified that what is the common column through which I can connect with each other and also the cardinality. And now I can just simply say save. Okay, so that is how you can define the relationships between multiple tables. But for this particular returns table, there is no relationship existing. So how do we tackle this particular situation? So why is this not happening? Because returns table is also a fact table, and orders table is also a fact table, and no two fact tables are connected automatically, and that is not doable. So in order to tackle that situation, we will be looking at um, a specific use case in the next coming video, probably, to look at how do we tackle this particular special case scenario. Okay, but just to demonstrate you what is that special case, I will just give you. So as soon as I try to relate both the tables together, you could see that there is a cardinality of many to many cardinality, and therefore this is something which is not um, commonly used. And how do we tackle this, I will be explaining that in the next video. Okay, but for now I'm just leaving it aside, since we are not going to address on the advanced topics but rather on the very basics. All right, now let's try to see the same example. So I'm deleting the relationship, and now I'll simply go to the report view, and let me try to build a simple report based on the regional manager, and from the orders I'll try to select the sales. Now, so if you observe here, what did I do? I simply drag regional manager from the people table and the sales column from my orders table onto my visual. And as you could see here, all of my four regional managers are having the same sales value, which is ideally not correct. Right, now how do we address this particular situation? So I can simply go back to the model view and relate both these tables, so that okay, so here it is region, and in the orders table as well it should be the region. And now I'll select save. Now automatically, if I go back to the report view, you could notice that the visual has automatically corrected and it got updated with the right data populated. And this is why data modeling is quite important. And without a right data model, it's very difficult to see the right results being displayed on our visuals. Okay, So that is the importance of having a right data model created on our reporting layer. All right, now that we've understood what is data modeling and how it is important or why it is important, let's see and understand when can this even be possible. Like when is data modeling be performed, or how or when can a data model be created. So let's say that when we wanted to create a data model between the two tables, then the important element to understand is that we need to have a primary and a foreign key relationship existing between the two tables. So what did I say? Let me go back to the table. So here uh, people table just holds the region based regional managers data, which is nothing but my dimension table. Why is it termed as a dimension table? Because it doesn't have any duplicates. That is the first thing. Secondly, it doesn't hold any transactional data like the metrics information. So it is just having the business specific information alone. And on the other side, my orders table has all the metrics information that includes the sales value, the profit, and other values as well. And therefore, this is termed as my fact table. All right. Now, here on my people table, the region column is referred to as a primary key because a primary key always have unique values without any duplicates in it. And while the same primary key when used in my fact table, it is referred to as a foreign key because there are multiple records for the same value, and therefore it is classified to be as a foreign key. And also the foreign key does have duplicate information. So as you could see here clearly, the west region has itself been repeated several times, while in the people table the west is having only unique record, and therefore this is called as a primary key, and the same primary key when used in my fact table is referred to as a fact table. All right, so that is when so by having the primary key and foreign key relationship that exists between the tables, that's when we are allowed to make a data model being created. All right, now let me go back. All right, so far we've been looking at all of them. Right now let's try to understand what is a dimensional modeling. So dimensional modeling on the other side is nothing but it's all about how we are arranging the dimension tables and the fact tables together. So it's the arrangement of tables within our data warehouse. So in our data warehouse, mainly we have three different types of schemas: star schema, snowflake, and a mixed or a galaxy schema. So usually we come across with a star or a snowflake, and sometimes we even try to work with a mixed schema as well. So primarily I'm focusing on the star and the snowflake here because it's commonly been used, and it's quite important as well. So in a star schema, as you could see, the arrangement of the tables looks like in a star structure, which means that we have one fact table located in the middle, and then we have multiple dimension tables structured around the fact table, or they are connected to the fact table. So all the dimension tables are directly connected to my fact table, and that is called as a star schema. While the snowflake on the other side, not all dimension tables are directly connected to the fact table. So as you could see here, in the middle we have one fact table, and around the fact table we have several dimension tables. So if I consider this particular table on the left top corner, so this dimension table is connected to another dimension table through which it is connected to the fact table, which means that the outer dimension tables are indirectly connected to the fact table, and therefore this kind of a schema or the arrangement of tables is referred to as a snowflake schema. Okay, so let me repeat this again. So a star schema has a direct relationship to all from all the dimension tables to that of a fact table, or all the dimension tables are directly related to the fact table. While in the snowflake schema, Not all dimension tables are directly connected, but they make use of a intermediate dimension table through which it is connected to a fact table. And therefore, this is called as a snowflake schema. Alright, now let's try to understand the cardinality. So, what is a cardinality? So, as we've seen earlier, right, cardinality helps us to identify what kind of a relationship exists among the different tables and what kind of a data or how the flow is happening as well. So in our cardinality, we have mainly four types of cardinalities. The first one being the one-to-one cardinality, and then we have one-to-many, many-to-one, and many-to-many cardinalities. So let's understand what are these cardinalities and how we can be able to create those structures as well. So in a one-to-one cardinality, it's basically referring to that. So there are two different tables, table A and table B. So every record in the first table has a uh, only one record in the second table, and that's when we call it as a one-to-one cardinality, which means that there is only one value existing in my first table to that of my second table. So there is only one-to-one cardinality. Whilst the one to many is nothing but when we have multiple records, every the one record on my left table has multiple records in my secondary table. That's when we refer that structure or that particular relationship as a one to many cardinality. So one to many is nothing but when we have one record in my first table that has a connection or that has multiple records in the secondary table, then it is referred to as a one to many cardinality. While the reverse is for the many to one, where we have multiple rows in my first table and only one record in my right table, that's when we refer that particular relationship as a many to one cardinality. And the last one is when there are multiple records in the first table that is connected to multiple records on my second table, then the both the tables are related in a many to many cardinality. And a good example to that is, as we saw previously, the orders and the returns table, because here order ID has multiple records, and whilst order ID in my orders table also has multiple records, which means that for the same order there could be multiple returns as well. And yeah, and that is why there are multiple records existing in both the tables. All right, so those are the cardinalities and the different types of it. All right, so with that said, let me go and try to create a simple schema and try to relate the tables together. So I'll go back to the, okay. So I'm on my Power BI desktop. So here I will try to create a new table, or maybe I'll try to create a new schema through which we will be trying to understand how the schemas are important and how the tables can be related to each other. So here I will try to create a new table for, maybe I'll just close this. First I'll try to show you an example and then we will try to create it. So I will quickly go and open up Paint, and here I will be creating an example on healthcare system. Okay, I'll keep it 20. Okay, so an example of a healthcare system. So what are the important tables that can come into picture? So in a healthcare system, that is nothing but uh, related to health domain. So the primary tables that I'm looking at here is uh, doctor's table, then Okay, there are doctors, there are patients, because doctors are required when there are multiple patients, right? So we have doctors and patients, and then we also have locations, because the hospital needs to be run in different locations, right? So therefore we have the locations table created, and then we have the date date table to maintain the patient's appointment information. Now, when patients are going to visit the hospital, then there is going to be some revenue incurred, and therefore we need that to be captured as well, which is nothing but my fact table, and that's going to be the revenue incurred for the hospital based on the patients visiting the doctors. So that's going to be the revenue. Now let's try to connect all these tables. So doctors connected to revenue, patients connected to revenue, locations. So from different locations we incur revenue, and from different dates we get the revenue. So likewise we are trying to create a schema. So let me try to explain this example again. So here I'm trying to explain this with a healthcare system data. So we have different so in a healthcare system the important element is the doctors, because without doctors there is no healthcare system itself. Therefore I've created a separate table for the tracking all the doctor related information, and when we have doctors, based on the doctors the patients would also come, right, to visit the doctors. So therefore we have the patients table being created, and the hospital does need to be run in different locations, and therefore we have the locations table, and to maintain the patient's appointments and other stuff we need to have a date table being created as well. Now when we have all the patients coming to the hospital, there is going to be some revenue incurred for the hospital, right? So there is some revenue being generated, and that is why I've created another table, which is my fact table called revenue. So in this way, we will be going to create a schema in Power BI and try to analyze the data through an example. So now let me try to replicate the same schema in Power BI desktop as well. So let us quickly create a schema. So for that, I will try to go and create a new table, which is called doctors, and the doctor table will have an ID and a doctor name, right? Let's say the ID is 1, 2, 3, and the doctor name is A, B, and C. And I'll hit on load. Then I try to create another data by clicking on enter data. Now let me call this table name as patients. Now what data can be stored in a patients table? There is an ID and a name again. So ID is nothing but ID of the patient, unique ID being created. Maybe I'll take 4 patients, and patient 1, patient 2, patient 3, and 4. And let me load the data. Likewise, let me create the third table, which is my locations. And within the locations table, we have the location ID and the location name. Location ID is 1 and 2, and location name is Bangalore and Chennai. Now let's try to create another table, which is again by selecting the enter data. And this table is going to be the revenue table. And the revenue table has all the columns, which is our okay, let me cancel this because I just wanted to look at the location key, which is lock ID. Okay. Okay, now let me click on enter data. Revenue, and the column would be for the location ID, which is location ID. And then we have the patient ID, and we have the doctor ID. Then we have the date and the fees. So for the location ID, I'm giving 1, for patient ID 1, and for the doctor ID 1, and a date as and fees is, let's say, 1000 rupees. And for the location ID 1, again, for patient ID 2 and doctor ID 2, for the date 24th December, and for the location ID 2 and 3, Jan, it's 800. Okay, for the fourth doctor, let's give another date, maybe 25th March 2024, which is 1500. And from the same location again for let's say another patient 4, and for the same doctor 17th June 2024, there was a fee of, let's say, 900. Now let's load this data and go to the model view. So here let me drag orders table, locations table, patients, uh, where is my date table? Okay, I still have to create the date table. All right, and my revenue table here. So let me quickly create a new table. I think I forgot the creating a date table. So let me create a table for date. And okay, I'll have to expand this before and maybe okay. So that's the date table. Now let me try to create the appointment appointment date. Okay. So in the appointment date, I will be using all the dates that I've used previously. 24th December 2023 and 14 Jan 2024, 25th March 2024 and 17th June 2024. And let me load this data. Now let me go to the model view and try to bring in my date table. All right. Now let's try to relate. So this is the doctor ID. So I am relating with the doctor ID and the patient's table. So patient's table, patient ID, and then the appointment ID date with the date. Okay, so I just arranged all the tables to represent the schema model, and therefore I have kept it in the same uh, in the image model itself, so it's easier for you to understand. So we have a doctor's table, locations, patients, and the date table, along with the fact table, which is the revenue, and all of them are related with each other based on the primary and the foreign key relationships. So this is how you can create relationships among different tables and define the right cardinality. So here, if you had observed, I have not defined any cardinality explicitly, but the moment I try to relate both the tables with a primary and foreign key relationship, Power BI, through its intelligence, has identified automatically what would be the cardinality that exists between those two tables. And cardinality is nothing but how the tables are related with each other based on the number of records that exist in one table to that of the other table. All right. So now let me go back to the report view and try to create another view out of these newly created tables. So let me just quickly, um, so let's say for a particular patient, who are the doctors who have seen the patients and on which day did the patients meet the doctor and how much fees did they pay. All right. Now you could see that for all of these patients, they have met this particular doctor and on this particular day, and this is the total fees that was being paid together. So, okay, let me try to. Okay, maybe I'll just rename the columns just to make sure that we understand it much efficiently. Patient name and Okay, which means that this is the doctor. So maybe I can just I'm trying to rearrange. So for this particular doctor or for this particular patient, um, this is the total amount of fees. So I did not, maybe I've missed to enter the details for this particular doctor, I believe. But this is the idea that I believe you get it right. So I'm trying to analyze the patient relevant information, like for which patient, like uh, which doctor did they meet and when did they get the appointment and what was the total fees being paid for that particular doctor, right? So maybe if I remove the date, you could see that what was the total fees being paid overall, like regardless on which date did they meet and make the appointment as well. So that is through how you could analyze the data, and perhaps you can also make some additional information being displayed, which is helpful for your business to make any deeper insights out of it. So I will stop here because I think for the first day itself it's too much to grasp. But I'll try to make sure that from the next video onwards, we will try to split this into different topics and we will be doing a lot of practical evaluations so that it's easier for us to understand the topic in a deeper way, and which will eventually help you to get the concepts in the right format. So, with that said, let me quickly give you a quick recap on what we have uh, went through on this particular tutorial. So today, as I said, this module is all about the data modeling part, and therefore I try to give you a basics of data modeling. I know that I've not yet covered, but I just wanted to give you a glimpse on the data modeling part. But in the next video, I will be talking about the data tables versus the lookup tables. What are they? And then I will try to give you the definition between the relationships and the merge tables through an example, and we'll try to go through the comparisons of both of them in a closer manner through a live example. And then yeah, I have already created a schema and a modeling, but we will be doing that again to deep dive into the two different schemas that we spoke about, and then we will try to understand how are they two different and why is it important as well. But in this video, I try to explain you the basic tester workflow and have given you a basic scenario of when the data modeling is important, because when we just try to drag and drop the columns coming in from multiple tables without defining a relationship, the data is not created or the data is not populated correctly. And in order to uh, update this data to show the right data, we would have to define a relationship between those two tables, and that is where relationship is quite important. And what is relationship? Relationship enables us to create a logical connection between those two tables, which means that only during the query execution it will try to go and look for those two tables, how they are two are related, and based on that it will try to query the data and retrieve the results in the report level. So therefore, it is not creating any physical memory, nor it's not creating a physical structure on the tables, but rather it's just creating a logical connection. And now yeah, so those and that's the relationship. Now how do we create a relationship? So relationships can be created in two ways. One is an automatic way and the other one is manual. So in automatic way, if there is a commonalities or a common column existing between those two tables, Power BI would automatically identify and define the relationship automatically. If not, then it would just leave it empty like this, and we would have to explicitly say that okay, order id on this particular table is related to order id on my other table by dragging and dropping on from one table to the other. and that would create a relationship as well. If not, you can also do the same approach by going into the manage relationships option on the home ribbon within my data model view, and click on the manage relationship, and here you can define a new relationship, and there you'll have to define from which table to which table you're trying to create a relationship. And you also need to select the common column that exists between those two tables to define the relationship, right? And then we have introduced about the dimensional modeling. So dimensional modeling exists within the data warehouse. So it's nothing but how the tables are arranged within our data warehouse. So in terms of schemas, and in general, we mainly have star schema, snowflake, and mixed or galaxy schema. And the importance of having the schema is nothing but how the tables are arranged in a data warehouse. So here we always have a fact table that has multiple dimension tables connected with each other. And how are these connected to each other? That defines the different types of schemas. So in a star schema, we eventually have all the dimension tables directly connected to the fact table. But in a snowflake, we have uh, different dimension tables that are connected to another dimension table through which it is connected to a fact table. Or in other words, dimension tables are not directly connected to the fact table, and therefore it is called as a snowflake schema. Whilst the other one, which is the mixed or the galaxy schema, there we have a combination of both star and snowflake, and therefore the term is referred to as a mixed or a galaxy schema. And then we try to understand what is a cardinality. So cardinality helps us to identify the exact relationship that exists between the tables. And how is that identifying? Through the different types of cardinalities, which is like one to one, one to many to one, and many to many. So in a one to one cardinality, it says that for every record in table A, there is only one record in table B. And in one to many, for every record in table A, there are multiple records in table B. And in many to one, there are multiple records in table A when compared to single record in table B. And in many to many, many records in table A are connected to many records in table B. So these I can relate to joins as well in SQL. So a one-to-one cardinality is ideally a um, a one-to-one cardinality is ideally a single direction, and one-to-many is uh, a one-to-one cardinality is basically an inner join, and a one-to-many is nothing but uh, a right outer join, and a many to one is nothing but your left outer, and many to many is your full outer join. So in this way, you can be able to relate to that of your existing SQL terminologies if you already are aware of. If not, that's fine. We will eventually be looking at all of these cardinalities through a lot of examples. So, with that said, I'm trying to conclude this particular day, and in the next video, I will be going through a lot of examples to demonstrate all of this uh, complex examples through a very simpler and basic terminologies. And with and until then, I hope you all like my videos, and please do support me. And I know that it's been a while that I've done this video, and from now on, I would be trying to complete the series and putting up all the content in a regular manner.